Solving systems of equations algebraically, and in this case a quadratic system. Let's call this equation 1 and a linear equation 2. Now you might recall you solved linear systems and the methods were substitution and elimination. In this case we're going to try substitution. So what I'm going to do is solve equation 2 for y, and then wherever I see the y in equation 1 I'm going to substitute that, which will give me an equation solely in terms of x. Okay, so let's solve equation 2 for y. That means moving this over, so let's x minus y is 1, negative y is 1 minus x, y is negative 1 plus x, so let's call that x minus 1. Next step, substitute. Hence the name. Substitute x minus 1 for y in equation number 1. So equation 1, x squared minus 3x minus 10 plus 2, instead of y, I write x minus 1, enclosed in parentheses, equals 0. Okay, let's expand and solve. X squared minus 3x minus 10, distribute, watch out if there's a minus, this isn't, but if there were, plus 2x minus 2 equals 0. And we're going to have a quadratic equation here, x squared minus x minus 12 equals 0. And I think that's going to factor. Let's give it a try. Okay, what do we got? X squared plus 3x minus 4x is minus 1x minus 12 equals 0. And so we have x is equal to 4 or x is equal to negative 3. Now, those are the x coordinates of our points of intersection, and we need the y values. So we're going to go back to equation 2, and I like to use the raw equation 2, not this here in case I made a mistake. So let's try that. We're going to go into equation 2. So we're going to substitute 4 for x in equation 2. Okay, let me just move this down a bit. Okay, 4 minus y is equal to 1, negative y is negative 3, y equals 3. That gives me the point 4, 3. We're looking for a point of intersection. And substitute 3 for x in equation 2 again. 3 minus y is 1. Well, 3 minus what? So y is equal to 2. Giving me, oh wait a sec, this was negative 3. So negative 3 minus, okay, let's go with negative y is equal to 4. And y is equal to negative 4. So this gives me the point negative 3, negative 4. So we have 2 points of intersection. One, 4, 3. The other, negative 3, negative 4. Now what we're going to do is we're going to first solve by elimination to show you the method of solving by elimination, and then we will verify our solutions to show you how to verify a solution. So I'm just going to clear this out, and we'll start over again, and we will solve by the method of elimination. Okay, elimination. In the method of elimination, we want to add or subtract these two equations to eliminate one of the variables. Now in this particular case, with a quadratic linear, the only variable we can eliminate is the y. We can't get rid of this x squared. So what we're going to do is we need the coefficients of the y to be the same. We need them both to be 2. So I'm going to take equation 1, just the way it is, minus 10 plus 2y equals 0. That's equation 1. I'm going to take 2 times equation 2 in order to get a 2 here. And I need to line things up. So this will be 2x. This will be minus 2y. this will be equal to 2. And now I'm going to, in this case, eliminate by adding, since these have the opposite signs. If they had the same signs, I would have subtracted. But I'm going to add these two equations. So this will be x squared minus 3x plus 2x is minus x minus 10. The y's eliminate, and this is equal to 2. Again, we have a quadratic to solve. Let's move this over. We get x squared minus x minus 12 equals 0. And our solution will be exactly as before. Factored, we get x minus 4, x plus 3 equals 0, x equals 4, or x equals negative 3. So then substituting into equation 2, we will find our 2 points, which are 4, 3, and negative 3, negative 4. Okay, so we can see the method of elimination yielded the same quadratic equation, giving us the same solution, which shouldn't be a surprise. We should have the same solution. Okay, let's take a moment and verify these solutions. Verifying is making sure that each of these points, 4, 3, is on each of these lines, so that it will be where the lines intersect. So to see, is 4, 3 on the quadratic, equation 1? Well, I do verification with the left side, right side. I'm going to substitute everywhere I see x. I'm putting in the 4. And everywhere I see y, I'm putting in a 3. So it gives us 16 minus 12 minus 10 plus 6, which is 0. So this verifies the point 4, 3 is on the line, or on the quadratic, x squared minus 3x minus 10 plus 2y. Will equation 2 be true? The left side is x minus y. This is a t table, right, since it looks like the letter t. And x, so this is 4 minus 3, which is 1. So this is true. This is true. This point 4, 3 is a solution to both equations, right? Since it makes both of them true, it's on both and therefore is a point of intersection. Okay, let's do the same thing. I'm just going to go clean this up. Okay, you just do another t-table, but to fit it in, I'm just going to clean this up, and then we'll check the point negative 3, negative 4. Okay, let's substitute negative 3 for x. Now I'm putting that in brackets. I'm going to be squaring negative 3. And negative 4 for y. So this gives me 9 minus negative 9, which is plus 9, minus 10, minus 8, which is 0. 0. So that checks. And negative 3 minus negative 4, which is negative 3 plus 4, which is 1. So this also checks. So the point negative 3, negative 4 is also a solution to the system, since it lies on both lines. Okay, here's a quadratic-quadratic. So we have the x squared, 8x squared, 6x squared. They're different widths, so if they intersect, and they both open up, so there probably should be 2 points of intersection. And this was to be omitted from the homework. Let's find out why, or let's give this a try and see what happens. 1 and 2. Now, I can't readily solve for y in either one of these, so I don't think I want to use substitution. So I'm going to eliminate the y value, and I'm going to do that by multiplying equation 1 by 3 to get a 15y, and equation 2 by 5. We'll make sure that we line things up and do our, in this case it'll be addition. Okay, so let's say 3 times number 1. 24x squared, let's leave some space, plus 15y equals 300. And we're going to take 5 times equation 2, 5 times 2, 30x squared minus 5x, and that's why the gap was left here, minus 15y, so that things like terms will line up, right? We've got nothing to line up there. And 5 times 5 is 25. Since these have opposite signs, we'll be adding. So this will give me 54x squared. Add. Now there's nothing here, 0x. This will be minus 5x. These cancel out, and that will be equals 325. So let's, we have a quadratic. There should be two solutions here. 54x squared minus 5x minus 325 equals 0. I don't know about you, but that doesn't look that easy to factor, which may be why we're leaving that out of the solutions. But let's use the quadratic formula. So a is 54, b is negative 5, c is negative 325. X is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. And let's substitute in x equals, okay, negative 5, so that'll be 5 plus or minus the square root of negative 5 squared. So remember, this will be positive 25 minus 4 times 54 times negative 325. So you know, this will be 25. Since it's minus and negative, this will be plus. We'll be adding. So the discriminant, the b squared minus 4ac, is positive, telling us that there are two solutions. Over 2 times 54. Wow, this is just too ugly to try and solve like this. So we'll go for the nearest hundredth. So it'll be 5 plus or minus root 25 plus 70,200 all over 108. Okay, let's just pop over here. So x will be equal to 5 plus or minus 70225 over 108. Let's get the two values for that. So we'll do 5 plus the square root of 70225. Divide that by 108. So 5 plus 70225. Make sure this extends out and that this line extends underneath everything. And that is equal to, okay, 5 plus, and who'd have thunk it? Square root of 70225 is actually 265. So that's 270 divided by 8. Just going off to a calculator here. 270 divided by 8. 108, sorry. Divided by 108 is 2.5. And x will be 5 minus 265. Right? I mean, it's 5 minus the square root, but we know that, over 108, which will be negative 260. Start over here. Find my calculator here. 260 divided by 108, which is negative 2.41. So those are our two x values. And how do we get our y values, right? Well, we have to go back up here and we're going to substitute in which case I'm going to go into equation number 1 and we'll work out the two y values to go with it. Okay, this is, you know, kind of messy, I guess, complicated. Probably why we didn't ask you to do it, but you know, the procedure is the same regardless. So I'm just going to, well, we can do it up here, I guess. We're going to have 8. We said x was 2.5, so 2.5 squared plus 5y equals 100. So this will be 8 times 6.25. So this will be 50 plus 5y is 100. 5y is 50 and y equals 10. So that gives me one solution, which is 2.5 comma 10. And the other solution, basically I'm going to put the 2.41 in and just take my word for it. And we'll negative 2.41 and 10.73. Close parenthesis. So we've got 2 points, 2.5, 10, and negative 2.41, 10.73. Now, we've had to solve this algebraically, but we can verify it graphically. I'm just going to go off to Desmos and graph these two, and we'll take a look at the points of intersection in a moment. Okay, here we are in Desmos. I've graphed the two. You could do this on your graphing calculator. You'd have to rearrange this. It would have to be y equals 100 minus 8x squared all over 5. And again, rearrange this to get y equals. I don't have to do that here. And there's negative 2.41 and 10.73, rounded to the 100th, and 2.5 and 10. So those are our points of interest, the 2 points of intersection of our graphs. Take a look at the examples in the book, right? It's still just solving. The idea is just to solve algebraically a linear quadratic or quadratic-quadratic system. Look at the examples in the book. Also look at the examples of solution, but the applications as well. And that will carry you through the next couple of days. So this one video will last us for 2 class periods of working on this stuff because there's a lot of work to do here. And we'll meet you at the next video.